Welcome to Math with Mrs. Bibb. Today I'm going to do some review and some notes because there may be some new skills that you have not seen before for your Algebra 2 Honors Summer Work Assignment. The first thing I want us to do is to sketch the graph of each linear inequality on your own paper. Use Desmos to graph it for you, and then this video, it says please watch the video attached to the assignment in Google Classroom to help. And this is the video that you're about to watch. I am going to pull up Desmos. So this is what you should pull up on your screen when you're doing your assignment. And you should type in each question. So I'm about to do that. I can make this smaller. Oops. Okay, hold on. Take me a second to navigate that. Maybe I click away from it. There we go. Okay. Okay, I'm going to type in exactly what it says. Y is greater than or equal to 8 divided by 5. Click beside of it. X minus 3. Now, earlier, I hope you saw that I actually picked up the screen where the graph is at, and I drug that screen away, and so that's why you only see just red. If you hit the home button, then that takes me to where I want to be. Now, before I draw this on my paper, I am going to highlight a couple of points. I don't think I want to use that one. What's this one? I'm going to find a good one that's actually on the graph, but it may not happen. It's probably up here. Hold on. Down a little bit further. Okay, here we go. This one, and then should be somewhere through here. Tracing along that graph. Oh, it's fine. We'll just pick one. We'll just do this one. So I am going to graph that on my coordinate plane. I'll draw that coordinate plane first. My graph is going to be tiny because I've got Desmos open below there. Well, that's bad. Let me undo that. Okay. Now I'm going to plot the point 0, -3, 0, 1, 2, 3. You're welcome to use graph paper if you have it. And then I'm going to plot the point 1.8750. So that means 1, 2. So I'm going to go almost to 2. Then I can see that this is a solid line because of that greater than or equal to. So I'm going to draw a solid line between those 2 points. And then I'm going to shade above that line just as indicated in the picture. So make sure you have shading when you are doing your assignment. Make sure you write down the problem, then draw your graph. Use Desmos to draw that graph for you, but draw your graph on your paper and make sure you have shading. Now I did actually shade outside the lines. Whoops. So let me go back and shade that. Try to be better at doing that. Okay, there we go. I have graphed number 1. Now let's graph number 2. Okay, I just exit out. You can also backspace. I'm going to type in 6x We do not have to manipulate this equation in any way. You can just type it in as it looks. I'm going to do less than. I'll change this problem. I'll scribble it out in just a minute. Less than -5. Okay, and let me see. I'll make this less than just because I wanted it to be a little bit different, and it was not different, and here's why. Here's why the shading was not below the line. The y has a negative coefficient, so if you were to solve for y and divide both sides by -5, you would have to flip that inequality and make it greater than, which then the shading would be above, which is perfectly fine what I have. I am going to find me 2 ordered pairs on that graph, and then I will draw it on my paper. Okay, hold on. I'm going to use 0, 1. If I want to use that one or not. I will. I'll just use that one. Okay, now let's draw the graph. Here's my coordinate plane. I'll make it just a little bit bigger than the last one. And then I will plot 0, 1. And then I will plot -0.83, which means it's almost at -1. Put a dot there. Draw a dotted line between the points. And then I will shade again above my line. So if you have a highlighter, if you have a colored pencil, do that shading above the line. And really what we should do, and I'm going to go back and do this just so you can see, we really should shade in the area, the complete area of our graph. So I'll go back and do my shading. So this is my coordinate plane, a piece of it anyway. It's okay if you shade outside that coordinate plane. And then you should make sure that your shading is within your entire coordinate plane. So now mine is. I'll go back and do the same up here. So I got to add some shading. And I went outside of it a little bit, and that's okay. So now what this tells me, and we'll see in just one moment, is all the ordered pairs that are in this area are a solution to this inequality. And all the ordered pairs that are in this shaded region or area are a solution to this inequality. Now, any ordered pair on this line is a solution because it's equal to. Any ordered pair on this line is not a solution because it's not equal to. So that's the difference between those two. Now let's go on to the next example. For this next problem, if you will write down number 3 and then just write that list of ordered pairs. -1, 5. B. -2, -7. C. 0, 4. D. 1, 3. E. 1, -8. F. 0, 0. Oh, and we do not have to draw the coordinate plane. Oops. Let's just get Desmos up here. Okay. And let's graph X. just a second. Hold on. X plus 2y is less than 6. Okay. Now, let's look at these ordered pairs. And you can zoom in if you want. There we go. -1, +5. As high as that goes is 3.5. So you can tell that at -1, +5, that would be, get my pointer, that would be here. So -1, +5 is not a solution for that inequality. Now for my next one, I'm going to ignore the fraction first because there's something special I have to do with that. I want to think about 16 and 4. Can I rewrite 16 with a base of 4? Yes. I could also rewrite both of them with a base of 2, but I'm going to rewrite 16 with a base of 4 first. So I'm going to have 4 to the second power to the negative n minus 2 is going to equal 1/4 to the n power. Now, I cannot do step 2 yet. My exponents are not equal yet because my bases really aren't the same yet. I have 1/4. How can I rewrite 1/4 with a base of 4? So hopefully you remember those exponent rules that says 4 to the negative 1 is 1/4. So a negative exponent means you have a fraction. And so 4 to the negative 1 is 1/4. And now my bases will be the same. And I can write my equation. My exponents are equal. 2 times negative n minus 2 is going to equal negative 1 times n. So distribute on the left. Negative 2n minus 4 equals negative n. Add 2n to both sides. So negative 4 equals n. That's the answer to number 16. Number 17, my bases are the same. 9 and 9 are the same. So I know negative 2k equals negative 2k minus 3. I'm going to add 2k to both sides. 0 equals negative 3. That's weird. That's not true. So this one is no solution. When your variable is eliminated, you're going to have one of two answers. If you're left with a true statement, then your answer is infinitely many solutions, which means no matter what you select, what number you select, that number will satisfy that equation. If you're left with a false statement, then that answer is no solution. No matter what number you select to put in for the variable, you will create a false statement. It won't work. Okay, now the next one is strange, but I can rewrite 243 with a base of 3, but I don't not remember what that was. So let's just go through and see. 3 to the first power is 3. 3 to the second is 9, and please write this down on your paper. 3 to the third is 27. 3 to the fourth is 81. And 3 to the fifth is 243. So I'm going to rewrite that as 3 to the fifth divided by 3 to the negative 2n minus 2 is going to equal 3 to the third. Now we've got to think about exponent rules. What do I do when I'm dividing bases that are the same? What do I do to the exponents? Well, hopefully you remember you subtract. So I would have 3 to the 5 minus, in parentheses, negative 2n minus 2 would equal 3 to the third power. So when you're dividing, you subtract. When you're multiplying, you add. Don't forget that. So now my bases are the same. My exponents are equal. So I've got this equation to solve. 5 minus the quantity negative 2n minus 2 equals 3. I'm going to distribute that negative sign. So 5 plus 2n plus 2 equals 3. I'm going to combine like terms. 2n plus 7 equals 3. Subtract 7. 2n equals negative 4. Divide by 2. N equals negative 2. That's my answer to number 18. Number 19. Now I have bases that are the same and I'm multiplying. So what do I do to exponents when I have the same base and I'm multiplying? Well, hopefully you knew to add. 4 to the negative 3k plus k equals, Can I rewrite 64 with a base of 4? Yes. 4 to the first power is 4. 4 to the second power is 16. 4 to the third power is 64. So equals 4 to the third. And now my bases are the same, so my exponents are equal. Negative 3k plus k equals 3. So negative 2k equals 3. Divide by negative 2. K will equal negative 3 over 2. Please no decimals. And please no mixed numbers. Leave it as an improper fraction. Now, to factor completely using the area model. The area model is just a box. So for each of these, I want you to write down the problem, and then I want you to draw yourself a box. In that box, n squared goes in the first box, b squared goes in the first box, and negative 21 goes in the second box, and negative 21 goes in the second box. Let's do that now. So n squared negative 21, b squared negative 21. Now, our answer is going to be on the outside. Our factorization is going to be on the outside. Now, I look at these like Punnett squares. That's what they look like to me. What do I multiply to get n squared? Because we're really multiplying. That's what this is here. I'm not going to put that x there. I'm not going to leave it. I'm going to undo that because I don't want to leave an x there. But we're really multiplying. Okay, so to get n squared, that's n times n. Now I need to multiply to get negative 21. Well, there's several ways I can multiply to get negative 21. Well, to multiply to get positive 21 is 1 times 21 and 3 times 7. But to get negative 21, then I need one of them to be negative, so I'm going to put negative 7 and positive 3 and see if that will work. Now, my goal is, when I multiply, I want these two to add up to give me positive 4. I want these two to add up to give me negative 4. So let's see if my first guess was correct. Negative 7 times n is negative 7n. And n times positive 3 is positive 3n. When I add negative 7n and positive 3n, do I get positive 4n? No, I do not. So I'm going to make this a positive 7, and I'm going to erase well, I thought I was going to erase. Maybe it won't let me because I'm going to have to scribble it out. And make that a negative 3. So this would be positive 7n, this would be negative 3n. 7n minus 3n is positive 4n. So I have my answer. I want you to remember, because I'm going to ask it often, the definition for factor is to rewrite a polynomial as a product of polynomials. So, as I said before, my answer's in the green. My product is two binomials, n plus 7 and n minus 3. Whoops, and I wrote 7. Did you see that? N minus 3. So n plus 7 times n minus 3. I just factored n squared plus 4n minus 21. Now I want to factor the next one. What can I multiply to get v squared? V times v. And to get negative 21, again we said 1 times 21 and 3 times 7. So I'm going to put minus 7 here and plus 3 here. Negative 7 times v is negative 7v. V times positive 3 is positive 3v. If I add the blue, do I get negative 4v? Yes, you do. So my answer is the product of v minus 7 times v plus 3. And that's my answer to number 21. We'll go on and do the same thing for the next one. Okay, draw an area model for both of these. In the first box, you're going to put the first variable. In the second box, you're going to put the constant. And our answer will be along the top and the side, the top and the side. And these two have to add up to give me this. And these two have to add up to give me this. Okay, so n squared goes here, a squared goes here, negative 32 goes here, positive 45 goes here. And then factors of 32, 1 times 32, 2 times 16, 4 times 8. And see, when I look at this, I believe these are the two that are going to work, but I got to get negative. So anyway, let's do the n first. N times n is n squared. N times n is n squared. N times n is n squared. What times what gives me a squared? A times a gives me a squared. Okay, and now I'm going to do positive 8 and negative 4 and see if that works. Positive 8 and negative 4. Does that work? Positive 8 times n is 8n. Positive n times negative 4 is negative 4n. Do 8n and negative 4n add together to give me negative 4n? And the answer is no. So then that means I'm going to make this, and I'm so sorry I can't erase. We'll make this negative 8 and make that positive 4. So negative 8 times n is now negative 8n. N times positive 4 is positive 4n. And negative 8n plus 4n is that negative 4n. Yes, it is. So now I have my factorization. It's the product of n minus 8 times n plus 4. That's my answer to number 22. Number 23. Multiply to give me 45. 1 times 45, 3 times 15, 5 times 9. I think these are going to be the ones that work. So if I put positive 5 and positive 9, this gives me positive 5a and positive 9a. Well, 9 plus 5 is not negative 14. So this is going to have to be a negative 5 and a negative 9, because negative 5 times negative 9 is still, let me get my highlighter, my pointer, negative 5 times negative 9 is still positive 45. And then negative 5 times a is negative 5a times negative 9 is negative 9a, and those two do add up to give me negative 14a. So my answer is the product of a minus 5 times a minus 9. So this is the kind of work I expect to see on your paper. You should have the boxes drawn. You should have factors written down. You should have the original problem written down. And then you should end up with a product of two binomials. Okay, I've got 2 more to do and then I'm done. Okay, so draw 2 boxes, 2 area models. And I'll just remind you, in the first box is that first variable. In the last box is that last constant in the middle. These two should multiply to give me, or should add to give me this. These two should add to give me this. And our final answer will be on the top and the side. On the top and, whoa, this side. Sorry, I keep hitting my controls there. I don't think you can see them, but I keep hitting them. Okay, there we go. Top and the side. Okay, and then my factors. Let's think about factors of 32. 1 times 32, 2 times 16, 4 times 8. And factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9. Okay, so in this first spot is going to go x squared for both of these. And what can I multiply to get x squared? X times x. X times x. Okay, and then I'm going to do 4 and 8. Positive 4 and positive 8. Those controls are too close to the side. There we go. Positive 8. Okay, and so 4 times x is 4x. Oh, I forgot. I'll get that in a second. X times 8 is 8x, and 4 times 8 is 32. I forgot to put that there. Forgot to put 36 here. Okay, so 8x plus 4x, is that negative 12x? No, so I need to make both of these a negative, because that will give me a negative 4 times a negative 8 will give me a positive 32. Then negative 4 times x is negative 4x. Negative x times negative 8 will give me negative 8x. And negative 4x plus negative 8x is negative 12x. So it's a product of x minus 4 times x minus 8. That's what works. And then the last one, I'm going to do positive 4 and positive 9, because I know 4 plus 9 is 13. Positive 4 times x is 4x. X times positive 9 is 9x. 4 times 9 is 36, so that's all correct. And then 9x plus 4x does give me 13x. So this is my product, x plus 4 times x plus 9. A product of x plus 4 and x plus 9. And that's my answer. So I hope that you'll be able to factor the area model easily. If you need help doing that, if you need more examples, let me know. I'm happy to give you more examples. Have a wonderful day.